Uh, anyways, here to talk power today. Thanks everybody for joining. Obviously, you heard our pitch yesterday about why we believe this is really important for our business and all of you guys, our customers. So I'm going to leave it right to them. You don't need me, but we've got some pretty awesome stuff to show you today. If you hear some music bumping in the background, that's my fault. So somebody can text me to turn it down. But genuinely, thank you for joining us. It means the world to us. And if you need anything, obviously, let us know. So, guys.
Awesome.
It's your show.
Good. Thank you.
Have fun.
Yeah.
Bye-bye.
Thank you, my friend.
Have fun. Have fun.
Enjoy that nice theater. Excellent, Vince. So
Cool, man.
yeah, he left it up to us. Hey, we had
Vince, nice to meet you.
We made it.
Yeah.
We took a trek from North Carolina today. It was what a fun adventure that was. I think everyone's pretty much said, hey, screw it. I'm gonna go join the holiday spirit and shop or whatever the hell they're doing, cruising the interstates. Before we get started, I just want to make mention, if anyone has plans to go out to CES, we will have, at the request of Meridian headquarters, who will be meeting with car suppliers and folks related to that end of the industry. We'll have the DSP 8000 XEs prominently displayed in a very nice suite in Vegas. If you have an interest yourself, or you have an end user that would like to come get a personal audition, with Ryan being their sort of Sherpa during that, please book time with Ryan to get that done. I'll get that in a second. That'll be the 5th through the 8th during show dates, and 3 to 5 p.m. Set the time up with Ryan. He will definitely help in any way he can. As Chris attested to, he's pretty good at closing those Meridian sales. All right.
Very good.
Thanks. We'll get started.
All right. So anyway, my name is Vince Luciani. Maybe I've met some of you. Hopefully, we will cross paths sometime in the near future. So, Jimmy, I think one of the main things that we are exceeding in what we do with joining Ryan and presenting a power line is to have a consultative approach to power. So we are here to help you guys, right? We're here when you get a project and power's not on the project. Let us help you get power as part of the conversation. And that's really what this training is all about. So just to kind of, what are we going to talk about today? We're going to definitely, do a quick recap of what we talked about yesterday. If you missed yesterday's presentation, it is available online. Is that correct?
We do. We've got about 9 minutes to trim some BS between us and the beginning.
Yeah,
that'll be trimmed and probably ready for Friday for distribution, but the reps will have it handy. Contact your local rep if you want to review that basic power discussion from yesterday.
The next thing we're going to cover, Jimmy and I want to kind of talk about the developing trends in power. There's a lot of products out there, which is great, right? Because it helps, it helps your bottom line, right, to have good, solid power foundation, in your systems. But there's a lot of things out there, so we want to kind of talk about the landscape and what's going on there. We're going to talk about our large format UPS, which we have right here. Let me move this chair out of the way so I can kind of reset the camera.
Yeah,
that is our large format UPS.
I'm really short,
yeah. But anyway, we'll be talking more about that and use cases for that, and then again talking about our design services, and then we also have our rack mount UPS here as well too. You can see that one on screen. So we depending on how big or small your job is, we have voltage regulation to,
and why we wanted to do this.
Yeah,
right, because that's important.
Yeah.
We get hit a lot from dealers who may come to us and say, I was looking at this brand or you, and this isn't a knock on brands, this is just a general statement. Savant Power or you, Tesla or you. I have solar, but I was thinking about maybe using UPSs. Rosewater comes up a lot, and that is one of those you're probably going to either use us or them. The other one was Sonnen battery. So we immediately say back, well, it's really it's not an either or. It's you're going to want to use both of us.
Yeah.
It's kind of like 40 years ago or 30 years ago when a homeowner was presented with a generator And they thought, oh, great, when I
Yeah,
have
that's all
no
I need.
power,
Yeah,
I'll have power.
Yeah,
Well,
yeah.
maybe that's what you remember from the sales pitch, but
yeah,
nowadays, a 4 to 20 millisecond transfer time in a line interactive UPS is far too great. Imagine an 8-second transition to a generator, and then it takes another up to 90 seconds to stabilize. Not enough.
yeah. So anyway, we'll be covering all that kind of stuff today.
Yeah.
So, the bottom line is, why is, solving these power quality issues important? Everything you guys sell is powered by AC, and when you have power quality issues, it reflects poorly not only on the experience, of the end user, but then when they have a bad experience, that unfairly reflects poorly on you, because you take your equipment gets plugged in, you are accepting unwillingly accepting responsibility for power quality when it shows up poorly on your on your equipment. So what does the bottom line, what does it do for you? Providing good quality power, it prevents lockups, right? It reduces those, it reduces equipment failure, and it really just improves equipment performance. And a lot of the some of the equipment you're selling, performance is what it's all about, right? You're trying to give a great experience to your customer. So the bottom line, the North American power grid has a lot of challenges, and and I can truthfully say North American power grid, because Jimmy and I at our previous company did a lot of analysis of power all over. What do you say? Thousands of
hundreds of dealers worth of information coming in, thousands of logs for sure, over an 8-year period.
And no matter where no matter where it was in the country, there was some degree of power issues. So why do we have them? Definitely, it's the age of our grid. There's you can the power companies themselves talk about their challenges in power disturbances. University research, think tanks, independent think tanks talk about the vulnerability of our grid. Actually, there was just an issue in our home state in North Carolina, where someone was upset. I don't know all the details, but they started taking pot shots at power at the local substation. So there is some vulnerability in the age. The fact that it's all above ground, that's a big problem, right? Because it's exposed to weather. You didn't even read my own damn notes. Population increases, right? More people move in, and with the environmentalist lobby, we don't get the power company increase in capacity that they want.
More people, more stuff, by the way.
Yeah.
The load, just
electric cars, right?
Yeah,
how much we talked about in and this is all putting taxing the grid and making things a problem, right? Giving us these, and we talked about these yesterday, these power disturbances, right? Mm-hmm. Whether they're surges, that's the one we know the most about, or we hear the most about that. But there are definitely a lot, and again, go back to yesterday's to talk about the intricacies of all these different types of power disturbances. We also talked about yesterday how these power disturbances map to problems, right? You've got immediate end of life type of issues, right? Surges, that definitely is in that category. You also have premature end of life, where equipment doesn't last as long as it does. Look at how many different power disturbances lead to premature end of life, and even lockups, right? So power is definitely an issue, and I think that when you go to sell power as part of your systems, that's probably the first thing that you should establish is, right, power disturbances are real, and they're not your fault as a as an integrator that's bringing this equipment in. That you need to set at that baseline of, look, I'm bringing you this great technology, but it's not going to work unless we have a good solid power foundation. So at this point, let's talk a little bit about the lay of the land, right? I think we all know about generators, right? Generators are, I'm a big fan of generators. I think they're a
Very
great.
economical.
Yeah, they're yeah, and there's so many of them out there. You can scale them to the size that you need. I think that's what's great around though. You know, there's a lot of pros. They are a source that will last as long as you need it to last, as long as you have fuel. Like my generator at my house is hooked up to our natural gas supply. So unless you're in Texas where the natural gas freezes, you know, you should have a steady supply of natural gas. And I know that my generator was on one day for 8 days. And that's one thing I'm not sure you can say about a battery system, right? You know, there's
An awful lot of batteries.
Yeah,
It's all just money though, Vince.
yeah. Yeah. But the cons with generators, right? The biggest one I think is the fact that they are loud, and sometimes they're not they're not allowed to be in certain locales because of the noise. They're not the greatest in quality, right? The output of quality, sometimes they require maintenance. And I know that mine I did not maintain, and when it came on this past a couple of months ago, it was kind of sputtering while it was working, and I could see. I'm in power, so of course I'm going to have power monitoring stuff on my house, and you could see actually with my LED lights, you could see that the lighting was all over the place because of the sputtering of the generator. So that's a big problem. The other problem with generators, like you already kind of hit on, is the transfer time, right? The amount of time that it takes. The power goes off. It takes anywhere from 8 to 15 seconds. Some of the newer generators even say, "Oh, we're great. We're like 4-second switchover." Well, for electronics, 4 seconds means everything's rebooting, and you guys know everything rebooting is probably not a good idea, right? So we are big fans of teaming up generators with our equipment, but we'll get that into a second. The next kind of category that we're talking about here is using batteries, right? As long-term solutions, right? So they came on to the into the marketplace, but their focus really wasn't about power quality, right? What their focus was more on
being off the grid, being clean, being green.
Being green,
and clean was really green, not clean power like like your Furman story or your AudioQuest story or your Shinyata and your other brands, your boutique brands, where you really focused on dropping the noise floor that was existing in the power line.
It wasn't about that. And then some of them I know have stories of and again, it depends on the market, right? Where some power companies, they can't keep up with the capacity. So what they do is they try to entice users to use energy off peak hours. So we talked about yesterday in Power 101 how electricity is a real-time entity, right? The power is that is being generated right now, or the power we're using right now is being generated right now. So if they can shift usage to nighttime hours, that helps them to keep up the capacity. So the whole idea behind these battery systems was, all right, charge your batteries at night, but during the day, instead of using the power company batteries, we used what has been charged up. There's a lot of losses in that, turning it from AC and putting into DC, and then taking the DC, turning it back into AC. There's a lot of losses there. Not necessarily should be sold on its return on investment is what we talk. You can of course add solar to that, right? Which now that starts to get it starts to get you to where you need to be, right?
And in many areas of the country, it gets you closer to that off the grid mentality. Less reliant on the grid for sure.
But the problem that we see with these battery systems, they're not focused on power quality, right?
That's right.
And especially on the systems that the whole idea is, switch from charge batteries during the night and then switch over to batteries during the day. That switching is not clean, right? That switching between sources, unless it's done very elegantly, which many times is not, leaves you with a power outage, a very short-term power outage. Some of them are as much as a 1 second switch over time. And again, when you speak casually, you think 1 second's not a big deal, but you take your router offline for 1 second,
Yeah.
the thing's gonna need to be rebooted, right?
Yeah, we learned, and it was around 2015 where I remember broadcasting to reps back then. I said, hey, we got to get off of line interactive UPSs, and that was a 4 to 20 millisecond transfer time.
Right.
Any
Yeah,
line
yeah.
interactive you'd buy,
Yeah.
that would be about the spec you were going to see.
Yeah.
And so really, when people come to me and they say, just yesterday, somebody said this brand, what do you have that's comparable? And the one thing I'm looking for, transfer time.
Yeah.
And so in any of this, look for a transfer switch. And if there's a transfer switch, there's going to be a transfer time.
Yeah.
You do not want a transfer time because it will be nowhere near what you're going to need in order to keep sensitive AV up and running without a blip.
Yeah. Very, very good. So I'm not, I don't think either you or I are saying don't sell people battery systems.
Oh,
yeah,
sure.
No,
Yeah.
it's like if your customer wants a battery system, they want to be part of the solution, right? Which I think that these storage of power away from a centralized location is an important thing. It's just that you need to augment that with addressing power quality, right? And I think that's what we're beginning to be talking about today. These products that you can do it, right?
Yep.
So again, I think for me personally, my biggest I'm the biggest fan of generators, and then using double conversion online UPSs that are voltage regulating, like the ones that we're selling. That combination seems to just work really well, right? Where because there's the great thing, and we're going to learn more about this later, about the double conversion online UPS, it acts as a voltage regulator. That means that when it's not being asked to do its primary function, which is to provide, either a crossover power or filling that gap, or long-term power, it's still giving you great value because it's acting as a voltage regulator. All the power is running through it. The AC gets turned into DC. The DC is there to charge the batteries that are internal, and then that DC bus is powerful enough to turn it back into AC full time. So we're regenerating the power on site, and so it's a voltage regulator.
That's right. Both in frequency, the sine wave, which you're going to show us a little bit of sine wave action in a little while, and in voltage. And you had made a comment, it's not the primary function that people have become used to.
Yeah.
Well, that's because we've all become used to this notion that a UPS, its number one job was like the generator 40, 30 years ago. It's just to provide power when there's no power.
Yeah.
And if that's the only reason we're using the damn thing, well, what's the value of it? Right?
Yeah. And I think that's as dealers, I think that's what we're trying to trying to change your mindset so you can change the mindset of your customer. That's why you see up at the top, we call these things we're going to just hammer it over and over again. Voltage regulating UPSs, voltage regulating, because we want the primary use of this thing to be the voltage regulator as much as it being a UPS.
Last point on that. With all that diagnostic information we reviewed over the years, the number one issue we saw was stability or lack thereof, or lack thereof of the grid. And so if you go anywhere and I say, hey, do you have clean power? I think I have clean power. I got dedicated, whatever. If I put a transformer outside, whatever. But if you ask people, do you have stable power? I would guarantee you, with no money on the table, but I would say 8 out of 10 people will say, I definitely do not have stable power. And what can you do to help me with that? That's the question we've been getting since the pandemic. What can you do to help me with my power quality? Weird word from a homeowner or a client rep. Stabilizing my power. Again, what are you saying? I can't believe a homeowner or a client rep is saying this to us. Those kinds of things have come up since the pandemic in a big way. And I think we're no longer pushing up a mountain. We now have the end user pulling us.
So the last reason why, I like a generator, and voltage regulating UPS solution, is the fact that it you're not worrying about battery times, these battery based, energy storage systems, a big part of them is controlling loads, being able to turn loads on and off. And the reason why you're doing that, you're trying to make the battery last as long as it can, which again, if you need to do that, you need to do that. But if you got a generator, you don't really need to do that. You can, it's a little bit easier to do. So answering the question, why do I care? Why, what is the big deal about this? Because this particular solution is focusing on power quality, right? We're going to be improving the performance of the electronics in many cases. We're going to provide longer equipment life. I've told this story so many times. My former life, I was design engineer, and when you design equipment, you're paired up with a senior engineer, right? And you design your stuff and you test your stuff, and you go through the design process with these senior engineers. And not one time in all of my design work did we ever say, okay, our product is finished, let's put crummy power into it and see how it works, and see, see how it does. We were always dialing in, with something like this. We're going to be using a Variac. I don't know if you can see it on camera, but that thing adjusts voltage, AC voltage. We would adjust it for 120 volts, eke out as much performance as we could out of it, give all that data to the marketing people, and they would say, oh, yep, the amps would do this much power and this yada yada, all this kind of stuff. So, giving your equipment good, good clean power is going to extend the life, and it's really going to increase the availability. At the end of the day, your customers are spending a lot of money for all of this automation in their house, right? Automating the lights, everything,
technology,
everything is. And when it's not available, when they can't turn on a freaking light because the system's rebooting, oh, that's not good. That's not good. So, just dive a little bit deeper into using a generator and a UPS. So if you read this graph, going from left to right is time, right? So you're on grid power, everything's good. Grid power shuts off because of a tree falls over the overhead power lines. You're going to have a little power outage. Actually, you're going to have a long power outage depending on how long it takes your generator to come on. Your generator is going to crank up. It's going to come up to a certain speed, and then a automatic transfer switch is going to switch over, and you're going to get this horrendous voltage transient, right? It's basically a mid-sized voltage surge that you would get from a lightning strike. It's that severe. And then you're going to be on generator, and then the grid comes back on, and that transfer switch is going to switch you back, and you're going to get another big transient. When you use a double conversion online UPS, voltage regulating UPS, all of that is smoothed over. There is no transfer time. I don't think we emphasized that before, but there's no relays for normal operation. Now, there is a relay inside these things that if you want to purposely bypass the unit, of course, you can do that. But during normal operation, when the AC goes away, the batteries just take over that DC bus seamlessly. There's no transfer time at all, and that's what the beauty of this system is. So, let's talk a little bit more about getting back to our conversation about the landscape. All right.
Sure.
When we look at our competitors, right, or the other people, I don't really
not competitors.
they're not, they're just other
just
people.
What's available. And
homeowners. The only two companies that really focus on power quality is us and Rosewater, right? That we're the only people talking about power power quality. Everybody else is kind of like we said, on that green bandwagon. When you look at our specs versus theirs, we are both regulating power that's coming off the grid. We both have zero switching. We're good there. Our big guy here, the big. Let me put the camera back on here. You see the big 10 kVA. In the bottom of that is an isolation transformer. We're going to show you in a little while what the attributes of an isolation transformer. So we have an isolation transformer in there, and the fact that when you pair us up with a generator, you have more of an infinite, and infinite in quotes, right? You know, if you're on a diesel generator, you know, you still have to have plenty of diesel fuel on there. But you know, that's the main difference
And
between
Justin
this.
wrote in when you were talking about the generator, he said, I live off grid and have experienced that with our electronics when it comes to our generator turning on. That's pretty interesting.
Yeah. I installed a generator in my house, and of course I did it myself. And I was testing it, and on the automatic transfer switch, I had the cover off of it just during the time. And it's like, all right, let me simulate a power outage. So I cut the breakers to our house, which of course discharges everything in the house, right? There's no, nothing on there, right? And then the generator comes on here in the background. The transfer switch goes over. The whole basement had this green arc and it was unbelievable. It was kind of scary how big of the transient is. So so anyway, if I had I do have this UPS at my desk. All my computer, all my lab stuff was okay, but the rest of the house is I just reduced its life a little bit by doing that. So when you look at the rest of the guys, right, and these are all names that you have heard of, and you guys might even be dealers of these guys. They still have their place out there, right?
Yep.
They do respond to the green aspect, or if the customer thinks being off grid, that kind of thing. But the thing is, if you're using those, you need to use a voltage regulating UPS on top of that.
In one form or another. And again, it could be the Rosewater, because that also does what we think is very important, the voltage regulation aspect.
Yeah.
But we just need something to carry us through the transition. Whether you're transitioning from grid power to solar or battery, or, you name it, battery storage from Tesla, Sonnen, those brands.
Yeah.
Savant Power. Yeah.
So this little graph right here, just kind of, I don't know, we put it together to kind of give you, where we are in the playing field. It's a price versus value. I know this is very subjective, right? We tried to be as fair as possible, and actually got some input from some of our reps, right? Say, how would you, put us on there?
Some of our reps, they, Savant, Sonnen, Rosewater, Brightbulb.
Yeah.
Some of our reps do us and those brands. Absolutely. Some of them do a couple or a few of those brands.
Yeah, exactly. Yeah. And so I think, when you look at our price point, it's a pretty good deal, for the fact that you're getting the value that out of it.
We like to pair, basically one 10 kVA unit to a sub panel, and just as long as we're sticking with somewhere around 8,000, 8,500 watts, you're dealing with about $18,000 retail. And so we generally will have more than one UPS in a home. It's two or three or four or more, because we're attacking sub panels at a time.
Yeah. And actually we have a design example that we'll talk about that in a second. So this is it, right? You can see the physical size of this guy is, I'll do the camera again. It's about 10 inches wide, about 32 inches tall, and about 30 inches deep. It's got 20 batteries in it, right? And at full load, it gives you about 3 minutes of backup, which if you teaming it up with the generator is more than enough. You're going to see here in a few minutes, we have a lot of battery cabinets, extension battery cabinets that are available, that if you want to turn it into a battery storage system, we can certainly do that. We can certainly do that. But you still get out of this particular version of a battery storage unit, you get power quality out of it. We're still focusing on power quality,
That's right. Zero transfer time, totally stable voltage.
Yeah. So we're going to be showing a demonstration of what an isolation transformer does for you. So this is not only performing the voltage regulation aspect, there's an isolation transformer inside it as well. It's got plenty of depth as far as current capability is concerned. So don't be shy about hooking your home, your theater system up to it. And it with some of the rack mount UPSs, we've shied away from hooking power amps up to it because of the current inrush aspect of it. But on the big boy, I think we're good. Putting whole theaters on there. And then, here's the mechanical drawing of what's on it. So let's talk a second here about isolation. Yeah, isolation transformer. Yeah. So from our discussion yesterday, right? This is how an outlet is hooked up to an electrical panel from the breaker. The breaker is the part that carries the energized. That's hooked up to the juice, right? That's the black wire. If it is wired to a national electric code standards, the return current goes through the neutral wire. But what is interesting is that neutral and the ground wire is there just for safety, right? The ground wire is, if you have a metal chassis, will be connected to that. So if the chassis would to be energized, maybe a screw gets loose, it gets lodged, and that there's a path for current to flow, unobstructed path for current to flow down that ground wire to allow the breaker to trip and open up, right? So that's the reason for ground. So ground and neutral get terminated to the same spot. So we all know that if there are two wires that are terminated to the same spot, the voltage between them should be zero, right? So that's kind of the the assumption that equipment manufacturers are going to say that neutral and ground are zero. So what happens is, when you put a high current load on that outlet, current is flowing through the line side, and then return path is through that neutral side. If that wire is really, really long, you're going to get a lot of extra resistance right through there. And if you measure your voltage across line to neutral, you'll actually get a voltage there, right? So this is one way that you're going to get neutral to ground voltage. Another way is just through RF energy, EMI, RFI energy that's in the air. You think about Romex wire that's running for hundreds and hundreds of feet around the house. It's basically an antenna at that point, and you're picking up a lot of wire. So the thing about the National Electric Code, it states very clearly that there's only allowed to be one neutral to ground bond in a system, and that is in the main breaker panel. All right, that's the only spot, except if you use went the wrong way here, an isolation transformer. So this is the schematic of an isolation transformer. It's nothing but a 1-to-1. That means 120 in, 120 out, right? Ground passes through the isolation transformer. However, you note that you can establish a new neutral to ground bond. So when they use that word bond, it's just a connection. It's just, I can connect those 2 points, right? So that's the only time. So if I park this big UPS that has a isolation transformer in it, if I can put it in my equipment room right next to my rack of equipment, now I have a very clean ground for my entire AV system. And I think that's the big attribute of the big neutral ground. So if we want to, real quick, I think we can
share the demo.
I have we've got a very convoluted system here, but or a setup. But what I have, So are you sharing screen? You got it?
Got it.
Excellent. All right. So what we have is this is a variac. Yeah, you can see that. This is a varying my voltage, but in this case, we're really not using it for varying voltage. We're just looking at I gotta change the.
I'll get Justin's question in a moment. Justin, I see you're chatting. I'll get to that in just a moment.
So I am going to turn the voltage off, and when I turn on this other all right, so that is the neutral to ground noise that we're seeing. So I've got my oscilloscope between.
Right.
Oh, I'm sorry. Yes, that's the neutral. Yeah, that's the neutral to ground voltage that I'm looking for. So that's the neutral to ground voltage. You can see it's kind of spiky. That is due to noise, and this is just hooked up to the electrical system in this building. I have an isolation transformer. Now, I would have loved to have used this one, but we didn't have 240 volts in our big one. But look how the noise just gets deadened when you go through an isolation transformer. So we'll go back to the first one. You see that red trace there, that's all the noise. And go back to the isolation transformer, and the noise floor goes to near zero.
Excellent.
All right. So let me go back over to this computer and reshare my screen over here. Jimmy, why don't you unshare yourself real quick?
Okay.
All right, I think we're back to sharing my presentation. We're going to go back to the oscilloscope to show you the voltage regulation aspect of it here in a second as well.
Okay. You good?
Yes.
All right.
So not only do we have single phase, so the UPS that we have right here is 240 volts in, then the split phase output of both 240 volt and 120 volt simultaneously. But what I'm showing you on your screen now is our three-phase version, right? And you saw from our presentation yesterday, hopefully, don't get bent out of shape when you have a three-phase job. It's not all that daunting. We're here to help you to go through that. Go through that. But if your power requirements require a three-phase, we can certainly help you on that as well.
Yeah, some of our larger homes have access to three-phase power.
Yeah.
And I just dealt with one in Naples where the initial conversation revolved around single phase, 10 kW. We needed battery storage. We needed to get into like 30, 40 kilowatt hours. We were able to present that. And then the load size started growing. And it was like, well, if only this place had three-phase power. They're like, well, it's a condo. Yeah, we've got three-phase power. So
Yeah.
it just allowed us to attack the application in a different manner.
Yeah.
Right.
Yep. So let's dive a little bit deeper into what we mean by our voltage regulating UPS. This is kind of the anatomy of a double conversion online UPS. It gets power, from the outlet. There's the first section, the AC to DC section. Sometimes they call it a battery charger or a rectifier. It is charging the batteries as well as providing power to the DC to AC inverter. So that inverter is electronically controlled, right? So you get very tight regulation of the output, right? It's very low distortion. It's a very quality output, and it does that full time, right? So again, we call it a UPS, but it's really 99.99% of the time it's a voltage regulator, right? So that is in normal operation. If the input AC goes away, the batteries just take over naturally without any relay switching or anything like that. And we're going to demonstrate that here. Now, actually, now's a good time as any, right? To go ahead and demonstrate that. There's no dropouts. There's no switching transients or anything. Here, so let me switch my oscilloscope back to.
I'm going to plug into the back of. Actually, I'm going to plug into the variac first.
Yeah, do the variac first. The reason why we are plugging it into the variac first, all right, is to show you. So when we turn this knob, you can see that sine wave goes up and down, and you turn it really fast because that's what like a voltage issues. It could drop out, it could come on, drop out again.
See the screen freeze around a power outage.
Yeah, so it's like it could go all over the place. All right, so let's now look at the output of the UPS while going crazy with the Variac as well.
All right.
All right, so
I'm just gonna say we're at 115 right now, Vince.
yeah. Now
I'm at 65. I'm at 197.
just go all
I'm
over
going
the
in
place.
between.
And here, a quick dropout. That click noise is me turning the Variac on and off. And the sine wave is stable. And I think that, that is at the end of the day what we're
That's what we're shooting for.
that's what we're shooting for.
All right, I'll stop sharing. Good question from Tar, and I think we'll address that. Tar, we're going to save the question about lithium batteries in large format. That's a great question, by the way. I got a theory, Vince. I think we both have come to grips on that. We'll let you guys know what we're thinking. Oh, Matt. Ha. Matt, not Tar. And Matt, thanks for joining.
So I think I moved ahead, but let me just go back to, I gotta do this thing. So the bottom line, you give these UPSs just about any signal, within reason, and we're going to give you out a good sine wave. I think that's, I think we've demonstrated that. All right. So as part of our design services, wow, where do we begin on this? Right. We have had.
It's funny. Matt just asked a question.
Yeah.
And Matt was, if you remember, part of that diagram. He
Oh,
gave us, I don't know, we had a discussion, I don't know, 3 or 4 years ago.
Yeah.
And then he kind of gave us a drawing, and then we kind of added to the drawing. And ever since then, it's really been a great visual aid. So I just got to say thanks again, Matt, for that. One thing we've done since is we keep getting asked, and the line of question will be something like this. Hey, I want my whole house on battery for 24 hours. And you're like, okay, cool. $250,000. Okay, half of the house, half of the time. And that just keeps dropping down until we reach some number that was in the customer's head. Oh, I can swing 100 grand or 50 grand or whatever it is. Well, in actuality, what we wanted to do was start presenting what we believe the best practice to be.
Yeah.
And of course, there's always going to be what is the end result everyone's looking for. And then, what is the ideal practice we want to put in play? And because we've got the ISO transformer integrated with the single phase UPS, we want to attack load types that are similar, lighting, separate from AV. And those two things separate from whatever other critical things the homeowner or client rep wants to add into. These are also critical loads. Can you help me with those? The koi pond, the wine chiller, the sump pump, the aquarium, the Sub-Zero, you name it. That's a list that's come from the homeowner or client rep.
Yeah. And I think that's one of the beauty, I think, of our solution is that it allows this siloed approach, right? Because it was funny. We were setting up the demo here, 10 minutes before you guys logged on, and Jimmy plugged in.
Oh, yeah,
where is the thing?
Yeah.
A little charger, a little charger.
Yeah.
And it screwed up the AC waveform, and it just shows you how loads can affect other loads if they're on the same circuit, right? And but yeah, it distorted the waveform, that little sucker. It's not if we were talking yesterday about power factor corrected devices. That one is definitely not power factor corrected, right? So anyway, so having this approach of having 10 kilowatt subsections allows us to silo these loads and really help you guys out. we had a situation. Remember, the guy said, he called up and he said, because my customer is really mad because every time they go into theater mode, as the shades are coming down, they hear crackling in the speakers.
Yeah.
It's like, well, yeah, we probably needed to have this conversation before you installed all that equipment,
Yeah.
and we would have, we would have caught that, So with our supplier, that we're using, we have access to a wide variety of different battery cabinets. So if you have a customer that wants a large battery storage type of solution, we do have the battery cabinets to to take care of those kinds of projects. Even to the point of we put this together for one of our reps. They presented a challenge to us. They said, I'm dealing with
two different challenges.
Yeah.
2 projects in Tahoe, no generator allowed. One needed 2 hours of backup time, one needed 5 hours of backup time, and they put that to us in kilowatt hours originally.
Yeah,
right?
yeah. So basically what we did was, well, let's go ahead and put some packages together.
Mhm.
So as part of our next round of price sheets that go out, we will have these non-generator type backup system packages available.
What did we got 10 kilowatt, 20, 30, 40. What did you end up at? 200?
240 kilowatt
Yeah,
hours
240
is the
kilowatt
big
hours.
one. Now
It's insane.
it's a lot of batteries, but
Yeah.
that is what it is.
Yeah.
That it is what it is.
This started becoming a question probably the last I'm going to say 18 months roughly, and maybe it's been 2 years. The first I remember Malibu saying we can't use generators. That was the first time I heard that. And then actually just very recently, I would say within the last 2 months, it's become escalated up in, hey, I need more kilowatt hour usage.
Yeah, and I'm not sure if there's anyone on the call from California, but I hear California, the whole state has banned generators. Something I heard.
Shit, I don't know.
Yeah, I don't know. I think I don't know. Maybe I have that wrong.
They're definitely not banned.
Okay, not banned. Okay.
Okay.
They would need all the help they can get.
Yeah, really. Yeah.
But
there are there's certain higher rent districts that have banned because of the noise, right?
Yeah.
So some design considerations. What we have found out in most cases, the electrician or the electrical contractor, the MEP people are not bringing this solution to the table. It is like open season for you guys to bring this solution to the table, and it's kind of interesting. You guys, I think, being considered the smart people, right? I think it's up to you to bring this solution to the table, because I don't know, Jimmy. Do you have any comments on?
I think it's time for the CEDIA channel to be focused on power quality and to show that it can't just be about quantity. And I feel like, although there are exceptions, right? I feel like overall the electrician is not the one pushing for this.
Yeah. And actually, the drawing that we showed a couple of slides ago about the design example, that came from a real world situation where the dealer came to us and said, "Hey, I need one of these for my AV system because it's a really crummy power in this house." He had taken one of our diagnostic tools, found out it was crummy power, and made a pitch to the homeowner and said, "Hey, we need to, I want to clean up power in the theater." And then they said, well, he was theater and lighting, right? He was doing those two because I'm responsible for this, so I really feel strongly. And then the homeowner said, "Well, if my power's so bad, what about my wine cellar?" Yeah, it's like, so he ended up putting what's the most we have now? 7?
7, yeah.
7 in a house is the most we've ever put in. So when you're coming to us, we just need to know what the electrical service is. Is it 240 split phase? Is it 208 3-phase? What are we working with? Is there going to be a generator on site? Is there going to be a battery system on site that we're going to be with? What are the loads, right? AV only? Is it, is there going to be lighting? Is there going to be other stuff? What is the required time on battery? If it's generator, we already know the answer to that. But sometimes, again, generators are not around, or there's something else. But if we have some kind of runtime, that it's good to know. A list of all the loads that we want to be putting on here, because we already know, I'm sure, that battery time is dependent on the electrical load, right? The lower the load, the longer the battery lasts. If it's new or retrofit,
and there's really only the only reason for this is actually most of the projects that we've dealt with over the last several years were retrofits where we put the large format UPSs in.
Yeah.
There was already a 60, an 80, a 100 amp feed going to, maybe it was the rack room, just as an example. Well, we can create a critical load panel if we need to adjust for sizing and make sure that just the AV ends up on the output of the UPS. But bring us that Romex, intercept it, put it into the back of the UPS, go out of the UPS to a critical load panel or the existing sub panel.
Yeah.
Sometimes it works out just right.
Sometimes it works out. Yeah.
And you're voila, you've just taken care of all the issues that you were fighting for however long you've been fighting for them. But usually dealers come to us reacting. I've got a really problematic home. We got one in Naples, another different project. And it's funny, Victor, he's had nightmare homes. And boy, did you get a doozy Monday
from
him. And, they come to us because, shit's hit the fan. And it's like, we don't know what else to do. And well, take the power out of the equation. Like, doesn't matter what's going on with the transformer or the grid outside. We'll deal with it. As long as we got the generator, we're pretty, good to go.
Yeah. And I think the main reason why we put this item number 7 in here is, don't dismiss it if it's a retrofit job.
That's right.
Yeah, it's like we've done plenty of retrofit jobs, and it works out because
new construction's even better, just because we can then say, hey, you got all your TVs also on this UPS
exactly
around the home, because you're not going to want that TV above the fireplace to also have a connection to the ceiling fan. We've heard about that many times, or the lighting fixtures. That's also come up quite a bit. So home run it back to as close to the rack as you can get it.
Yeah. And we'll definitely talk about the physical space. Luckily, these are, they're not huge when they're the UPSs by themselves. The battery cabinets can get a little bit better. They do put out some noise. So, if you put them in your equipment closet with your racks that are already making noise, it usually works out. I don't think we've ever had an issue where the noise exceeded what the rack rooms.
Well, we did. We had one where it was like adjacent to a theater, and in that particular area, the theater's where the money seat was, and that customer, that dealer, actually created I'll call it a hush box. He would say it did not quiet at 100%, but it took it down to about half. So there's a way to custom work these things, which is always good. That's what I love about this channel of business.
Yeah. So again, we're here to help you. Jimmy and I started this thing to help you guys and to kind of continue the consultative approach that we've always had in looking at this. So what to expect during installation?
Number one, we got this one this morning. Actually, last night at around 11:30 p.m. and then more questions this morning. We don't know what our input's going to be. We're not sure on the output. Okay, well, we'll ship a 240 in, 240 out. And then last night it was, hey, we got 208 we need for the output. I'm like, oh, okay, and 208's our input. I'm like, oh, well, that was another unit on our price sheet. Had we known, we could have wired it up. We could have set the menu selection for you. It is doable in the field, though, and it's not that difficult.
Yeah, but we if you tell us beforehand, we'll pre-configure it, which is good. Just so you know, with the batteries in it, they weigh a little bit of have a little
350 pounds.
I think three and some change.
So
be aware of that. The little shipping container, so it comes on wheels, right? So it's on wheels, but the little shipping container has a little built-in ramp so you can get it off of the out of the shipping container, but it is going to be on a pallet, so you got to figure out how you get off the pallet. Many times the dealer is sitting next to the electrician and they give us a call, hey, will you just talk this guy through it? And it's like a 5-minute conversation. It's like, because the electricians are used to to what's going on. 3 wires in, 4 wires out. So the input is going to be 2 hots and a safety ground coming from the main breaker panel or a sub panel. The output is going to be 4 wires, the 2 hots, a neutral, and a ground, and the output is going to go to its own critical load breaker panel. And like you were talking about before, everything that you're responsible for, have those circuits go back to your critical load panel.
There's a question about that, and Matt asked, not Matt Wetzel this time, I don't believe, but another Matt. He said, hey, what if your TV is 125 feet away? And I think you brought that discussion up earlier when you were showing the neutral to ground return path. Basically.
Well,
so what do you think about that?
So the good news is this: TVs don't, modern TVs don't pull a huge amount of current, so the wire length is not that important, or it's not that detrimental. Like if you had a subwoofer amplifier that's 125 feet away, I'd be more concerned about that than the TV. But the other thing you can always do is increase the wire gauge, because we all know that wire resistance, there's a resistance per foot of wire. The larger the gauge, the lower the resistance. So it can be very easily overcome by cranking up the wire gauge.
Yeah, that's a beautiful point.
Yeah.
Yeah, cool.
We've got, very detailed instructions, but you also have Jimmy's phone number and my phone number if you ever have any problems.
More important, your phone number sometimes.
We've got that, and I already talked about this, right? It's a very easy connection. 3 wires in, 4 wires out, going to a critical load breaker panel.
Yeah, cool.
All right. So now the rack mount UPS.
Yeah. So $18,000 retail is not that huge. The product is kind of big, and if you don't have space for it, or it's too noisy, or you don't want a hardwired unit, or your system scale is just not that large. Maybe we're only dealing with a single 20 amp circuit or a couple different racks on their own individual circuits. Then we've got a 2RU voltage regulating double conversion online UPS for you. So big or small, we'll be able to satisfy the #1 problem that we've seen around the US, the unstableness of the grid, and bring that stability into the rack. Whether we service the whole rack from the sub panel, as we just talked about the large formats, or we do it right there at the rack. 1000 VA, 2000 VA, 3000 VA product. At Apex, freight is included no matter what you buy. That could be a big ass screen in a crate, or just this box that we put our webcam on to try to make sure our height was just right.
Yeah.
So 30-something pound box. But the idea though is that Apex brings ease of doing business. That's what we love about partnering with Apex.
Yeah.
And the other thing that we love is we can go to a brand like Enavolt and grab from them what we see the best from them being the rack mount UPS.
Yeah.
Go to 360 Power Quality, who's out of Chicago instead of Enavolt in Atlanta, and grab from them the large format UPS and the ability to customize these battery cabinets to almost the nth degree, 200 plus kilowatt hours, right? If we need a special product, we've already hit them with, can we get a certain size ISO transformer? Can we do the custom battery cabinet? They said, shit, you can do whatever custom. We said we needed 2 hours. They were like, 2 to what? You just name it. We'll do it. They do it for data centers all day long. So it's been an incredible partnership. We were able to curate the line. We'll continue bringing products from where we see maybe, best practice, most ideal, most sought after, you name it. We're going to try to, curate a power category in Apex that addresses all the needs that we've got.
Very good.
Yeah.
So we have the 1 kVA and the 2 kVA in stock. The 3 kVAs will be here first quarter of next year.
Yeah.
So the 1 kVA is 1,000 watts. In amperage, it's a little over 8 amps. Now it has a 15 amp plug. We refer to it as the 15 amp unit, but it really delivers 8 amps, but it has a 15 amp plug on it. The 2 kVA delivers about 17 amps. So it looks like a 20 amp circuit, right? Your 20 amp circuit, you don't want to load down to the full 20 amps, but it can supply whatever you're going to normally pull off of the 20 amp circuit. It does have a 20 amp plug. So the one of the blades is going to be turned sideways. So make sure you have 20 amp surface before you order that 2 kVA unit. All of our UPSs, whether they're the large format or the rack mounts, come with an SNMP card included. The 2 kVA and 3 kVA rack mounts have the rack rails in it. The 1 kVA, it only has 2 batteries in it, so it really doesn't need the rail kit, but the ears, of course, included with everything. So I put we're here at the tail end. We want to talk a little bit about the competition, because it's very, very important to when you're looking at other products, or you're up against other products, to know what's going on. You've heard a lot about line interactive UPSs. This is the kind of the structure of what a line interactive UPS looks like. It has similar characteristics. It has the rectifier or battery charge circuit. It's got the inverter section in there. But as you can see, there's a relay in there. In that upper right corner, there's that relay. Most of the time, a line interactive UPS is just passing power from the input to the output. It may go through some cursory power conditioning. It's not very it's not greatest power conditioning. I mean, it might have a filter in there. It's not anything that is worth the amount of money that you're paying for it, because 99.9% of the time it's going to be in this mode of operation, right? It's really it's just not a good value in my opinion. When it so the biggest part about it is, if you've got crummy power coming in, that crummy power is going to be just passed to the output during normal operation, right? And that's just the misnomer on that, right? During backup, when the power goes away, the batteries are going to take over powering that inverter. However, you can see that relay takes between 4 and 10 milliseconds to switch over. That is the biggest detriment right there, because depending on the piece of equipment, that 4 to 10 milliseconds can cause a problem, right? Cause a reboot, cause a glitch, or require a reboot, right? It may just lock it up to the point where, okay, now I gotta physically go out there and unplug the thing.
Mm-hmm.
So, this is a graphic I put together. This is the output that we've seen on many line interactive UPSs, right? So reading from left to right, you get your sine wave. That's the sine wave that you're getting from the power company that is passing through the unit, right? You can see right there at that point of, where the power goes out. Now you've got 0 volts, right? For 4 milliseconds, I drew it there, right? When that relay switches over, just like when I was switching over the transfer switch on my generator, you get a huge transient. And then you see after that point, that is not a very good sine wave. That is a crummy sine wave, right? Because a lot of these things are not true sine wave output. The terminology that is often used, they'll say sine in the name. I love that. Good marketing, right? Simulated sine wave. What that means? It ain't a sine wave. Modified sine wave ain't a sine wave. Approximated pseudo sine wave. These are all actual outputs of line interactive UPSs that I pulled off of Google. So yeah, this is really what's going on. This is what you want.
And to be clear, we have done plenty of demos where we can vouch that those are definitely sine waves that we've seen.
Actually,
that one on the top right looks very familiar.
Yeah. We know that one.
Yeah.
But that's what it should that's what it should look like,
Yeah.
So again, we're here to to be part of your design team, right? We want to I think what's really cool about this industry, I've been associated with this industry a long time ago. I was part of the Cedia family. I went away for it for a long time. And when I was audio aware, when I was young, right, I was going into those 2-channel stereo shops, right? Who was it in Raleigh? Hi-Fi Buys,
Hi-Fi Buys,
Hi-Fi Buys, and Audio Buys.
Hi-Fi something, Hi-Fi House or Hi-Fi something, Hi-Fi Kelly's.
Anyway,
I don't know, whatever.
Anyway,
Yeah.
back in those 2-channel days,
Because you were preceding me a little bit.
yeah, I know.
Audio Advice was definitely around.
Yeah, but it was really cool. And and then the home theater craze came around.
Yeah.
And now you guys had to learn more, right? And then I come back to the industry. Now you still know everything there is to know about audio, everything there is to know about video. Oh, you took lighting on in the meantime. Oh, now you're taking on security, really? Oh, and control systems and shades.
Yeah.
It's like, and the thing is, you took IT. I remember in the days when IT was a separate company, and then you guys would curse because like they screwed up the fucking network, and now I gotta
Finger pointing.
you know, it's like, yes, yeah. So he's like, I got to take, so let's take power into your house. Now, I'm not saying become electricians or anything like that, but at least be aware of power and let us be your advocate to make sure that the infrastructure is there and good.
Yep. We do have some questions, and I love this slide, by the way, because this brings it home what we do and how it relates to Apex. And immediately, we had a theater job, 21 speakers, and maybe it was more, but I think it was 21 total architectural speakers for the theater. And generally, there wasn't a drawing showing the power to each speaker, right? Like but the dealer asked, well, what's the power going to look like? And I'm thinking, well, you know, the Romex has got to run to each speaker, right? And maybe you could daisy chain it if you wanted to. But then we got to talking and, hey, Vince, how many circuits should we be dealing with here?
Yeah.
And, you know, how many speakers on each circuit then? And so that's where the power design became a part of the Meridian. This is just a typical page out of what would be somewhere between 20 and say 30 or so pages of a Meridian design. Good, better, best kind of package that we put together. So yeah, it's pretty cool.
Yeah, so we're running, you know, the Meridians, every wire is a home run. I think that's a part of that is out of necessity because there's really no room inside the Meridian back box to do a junction.
Oh yeah, right.
So everything runs home runs to a junction box that is near our critical load panel, right? So we'll do that. You get the benefit of the UPS being next to this critical load panel of having an absolute clean ground. Right. And it just, you know, it's there as much enhancing the performance of the Meridian system by having a very, very clean noise floor as anything else.
So we've got some questions, Vince.
All righty.
And Matt hit us hard today.
Yeah.
But I think it's awesome just to hear the engagement via chat. If anybody else has questions, by the way, it's probably easiest just to write it up in chat and then I'll review and then we'll address it. So let's see where we want to start. Since we just talked about rack mount UPSs, there was a question from Chris, actually. Chris asked, do we have a detachable power cord? The answer is we do not on the rack mount UPSs.
Yeah.
And why is that?
You know, I think it was just a design I don't know. The designers just designed it not to make it, you know.
I know if we went to try to get the detachable cord, it would require a whole new UL certification.
Yeah, that is true.
All right. So maybe path of least resistance, maybe we were able to get that a lot faster because we already had the UL certification.
Yeah.
And we're waiting on another company who we initially spoke to, I don't know, 5 months ago. We're in the UL phase now, and it's not a cost thing as much as it is a longevity thing. How long is it going to take? And probably by Q2, we think we might actually have product from Germany that will be available to us to sell in North America.
Yeah.
So that was the detachable power cord question from Chris. Rack mount, how loud is it? It's not any quieter than what you're used to, probably. If you're using an online double conversion UPS, this is probably about the same, maybe a little bit less, but it's not because it's less audibly, it's less in the frequency it's generating.
Yeah. I mean, one thing, this has been on the whole time. I don't know if that makes any difference to you.
Maybe I get used to it.
Yeah.
I mean, we are probably between 45 and 49 dBA.
Yeah.
Right.
I mean, the thing is, I'm talking to, you know, a whole crowd of audio aware people. You know, in order to get a noise figure, you know, they're digesting that noise down to one number so that we can compare two things. But we all know that you know, perception is frequency dependent. So, you know, it may be that, you know, something has a zizzy a tone to it, and its number is less than another number that, you know, the number is lower, but you know, it's more apparent. One thing I can say is, my perception is that it's lower than you know, other products that we have previously had, but the number is probably very similar from that standpoint.
Okay, so we have a question on, again, we'll continue with the rack mount and then we'll move to large format. The 2 kVA we said were 17 amp. Is that 17 amp rated?
Yeah, I
And
can't,
then
yeah,
the 3 kVA, so am I just doing this right here?
yeah,
Divide by 120, we're at 25.
yeah.
All right, so the
What-
3 kVA would be.
It's probably a little less than that because while the 1 kVA, it's single, it's one power factor is 1,000 watts, 1,000,
Oh, thank you.
these
Yeah,
are just a little bit less, so, but it's like,
All right, hold on, hold that thought. 22.5 kVA, and that was
Yeah.
for Justin. Justin asked that.
yeah.
All right, so at
It's
point nine.
probably best that we look at the data sheet, and I hate to give you wrong numbers on this thing.
All right,
so,
well
yeah.
then ballpark it.
Yeah.
I mean, ballpark it, and we've got a spec sheet, but
Yeah, yeah.
those seem to be pretty
Yeah.
in line.
Yeah.
And how are we dealing with surge? That came from Matt. Well, we're not right now, Matt. Actually, one of the hardest products for us to source was somebody that was already doing surge elimination. But what we can say, two things. We are taking care of the number one thing, the number one problem that we've seen over several years, which is unstable voltage. That is a big issue no matter where we're at in the country. An isolation transformer inside a large format UPS is one hell of a surge filter. Does it eliminate? No. Would a AC to DC to AC converted UPS eliminate a surge? No. Should you use protection ahead of both of these things? Absolutely. Should you use protection after the large format UPS, like as Matt said, the PF420? What about it?
Yeah.
Yes, still use that.
Yeah.
I mean, that's the best practice.
Yeah, and it is a good practice. We are actively looking for solutions because, I think Jimmy said it best when he said, we are curating a line of products, right? That's what we're trying to do. And we are actively pursuing that.
All right. And here's another one, gloves off. I like this. Lithium battery.
Yeah. So, lithium batteries, they have a higher energy density. That means they are lighter weight and they can store more energy. The thing is, the price of lithium these days, because the cars need a higher energy density. They need something that is lighter in weight and holds more energy. So they're eating up all the lithium. So lithium products, tend to cost a little bit more. If your UPS is teamed up with a generator, you don't really need any more energy storage, right? You don't need that length of time. So that part of it goes away. So I think it just kind of depends on on the application. I think there are definitely applications where lithium batteries make sense. But sometimes we gravitate towards the newest thing because that's the hottest technology, the newest stuff out. In this case, I'm not sure it buys you any. The extra cost, it's like prepaying for the batteries, right?
Yeah.
It's like,
I go buy a EV car, I'm prepaying for all the gas I would have bought, maybe over 5 years, 10 years, whatever it is. But honestly, I don't know that price, like I'm looking at the list of dealers on this attending here.
Yeah.
And I don't know that price is going to be the thing that curbs the decision.
Yeah.
Although it's at least double, and it has gone way up, and it may be leveling out some. Here's what I'm concerned about. You mentioned it. The EV cars are buying up the lithium. We already have seen in the presses, and by the way, when Vince and I knew we were going to do this, when I knew ahead of you, and then you said, I want to come on board, right? Lithium was going to be the thing that we hit the market with. And then we started seeing all the press about lithium and how in short supply it was. And I don't know if this is going to happen, but in 6 months to a year from now, I wonder where we will be at if we all, as a channel, or maybe even just us on this WebEx, if we all said, hey, customer, lithium's great. We don't have to change the battery for 5 to 10 years. Okay, cool. Hey, we don't have lithium batteries anymore. So you know what's really cool? Lead acid. Lead acid's really cool. I mean, lead acid you can get anywhere, and it's so recyclable. I don't foresee an issue there, like what I think, and we kind of go back and forth on this, but I saw some senator in a congressional hearing make a statement that we need hundreds of mines, given the fact that by 2030, so many of us in the US need to be on EV cars. Therefore, the mining of lithium and cobalt needs to go up and up and up. Hundreds of new mines will need to be established in order to try to even meet that demand. And if the car guys are struggling to get the supply, what does that mean for current consumer electronics? If anybody has been around for time, and we go back to needing relays or shit, just the past 2 years, we need semiconductors. Who gets it? The car guys get it.
Yeah.
Their orders dwarf our orders, combined
Yeah.
orders.
Yeah.
So that's the concern.
Yeah.
Is it legitimate? I don't know. I'm not smart. I'm an idiot, but it's something that I'm thinking about. So lead
Yeah.
acid is where we're at right now. If in a 6-month period, a year from now, we think that economy of scale has changed, then maybe we revisit it and
Yeah, the
hit
good, the
something
good
else.
news is we can get lithium.
We
can
Yeah.
add that to our product line if you guys,
demand it.
demand
If you
it.
demand it.
yeah.
Yeah.
I mean, it's
Right.
possible. It's just,
Okay,
any other
so
questions?
here's this is a good line of questioning. This always comes up. I love this question because it's come up, and it's because someone has dealt with a UPS brand that has had this issue, and they want to make sure they do not have this issue anymore. And I'm going to tell you, Justin, great question about UPSs and if batteries die, does the unit still pass power? There's two questions that always come up, when one of those is asked. If your batteries die, do you still pass power? The answer is yes.
They
Okay,
still regulate. We're
That's
not just
right.
pass. We're
That's-
just,
that's-
we're
that's
still
correct.
regulated.
That's
Yeah.
right. Okay, the actual question in this case was, if power goes out, batteries deplete all the way, power is restored, does our unit come back on? And the answer is yes, we come back on with mains power restored. We're charging our battery and we're passing mains with that double conversion voltage regulation that we made such a fuss about.
Yeah.
Yeah, good question. Yes, and that is without the need to hit a button to turn back on the UPS. And I know that generally when somebody asks this question, they have dealt with, I used to get the question, I was just the other brand I worked for.
Yeah.
And there was a 3-letter brand and another brand that ended with Max. And that's why they asked the question, because those brands did not come back on automatically. And when batteries failed, they did not pass power.
Gotcha.
Yep. Hey, but a dealer hit me with this last Thursday night. And they said, we stopped selling UPSs because of those two reasons. Well, and they said that was like 7+ years ago. And I'm like, man, a lot's changed in 7 years. And actually, you're shooting yourself in the foot if you don't use the voltage regulation coming out of the UPS. That's the thing you need the most right now.
Yeah.
Anyhow,
Anyway.
great questions. Yeah. So I don't see any more coming in, but if someone wants to ask a question, we'll stick around another couple minutes. It looks like we ended a little bit early, so
Yeah.
hopefully everybody appreciates that. I know an hour and a half is a long time to spend about power.
Yeah.
We are so thankful that you chose to do that. Hopefully you got something out of it. Appreciate the engagement.
The one thing I hope you got out of it.
Yeah.
Sell voltage regulators, not UPSs.
Oh yeah. I don't know. Absolutely.
Yeah.
We're gonna keep saying that until we're blue in the face, because we learned. We actually said it at one point, man. If we could ever do it differently, we would have said these are voltage regulators, not UPSs. Because the second you say UPS, I liken it to like 10 years ago when we used to say surge protector. When you say it to the homeowner, I got a UPS for $2,000. They're thinking, wait, in my brain, a UPS is $150. You say, I got a surge protector. And they say, wait, instead of $2,000 for a surge protector, in my brain, I got that white thing.
Yeah.
Right here.
Yeah.
That white strip, it's like $10 at Home Depot. And that's the problem with saying stuff like that, is the homeowner immediately, if you ever have to say these words in front of the homeowner, here, sign the bill, and here's the things we put in it. Immediately they're thinking you're ripping them off. And in this case, I think they'd all agree that there's a lack of stability on the grid, and you're trying to address that. You're trying to make sure that that experience that you're bringing to them is uninterrupted.
Yeah. Well put. Well put.
All right. Well, Matt, sorry, I wasn't trying to avoid your question. Matt says our 15 kVA and 25 kVA units coming. We do have plans for a larger than 10 kVA single phase unit. Keep in mind on the 3-phase side, we do go larger, 10, 20, 30, 40. and we can parallel the 3-phase units if we need to. On single phase, we do have plans. It will probably take us at least 12 months to be able to bring a larger single phase UPS in. I will say that a lot of what we deal with seems to fit within 10,000 watts. That is not always the case. We literally did just have 4 units that we put together for somebody out in the Rockies, and that was 2 UPSs to drive the whole AV system, because that was the one that had the TPI amps.
Yeah.
That needed at least 720 amp breakers by itself.
But you got to remember also that 2 10 kVAs will do the job of a 20 kVA, and you get the added benefit of isolating the loads, right?
I think if and you're right. You're right.
Because there's
sometimes they're probably like, well, shit, then I got to use 2 different sub panels. I'd rather just use the one. So I think there is a viable reason for, say, a 20 kVA.
Yeah.
And if we did a 20, I don't know that we're going to do a 15, Matt. We'll just do a 10 and a 20. We are working on the 20. But you're right.
Yeah,
I mean, for now, we have definitely had multiple occasions where it's not just one 10 kVA going in.
Yeah.
All right. So I think I like the breakout of multiple. Okay. Matt likes that. Could you briefly describe the maintenance bypass switch? Oh,
good.
Yeah. All right. We learned a lesson once, probably 3 years ago, I'm guessing. There was a smoldering coming out of the back of a large format UPS in a home, and the homeowner went crazy because imagine they're seeing smoke, they're thinking something's on fire. The UPS had been in the field for more than 3 years. It literally had a sticker that said replaced by September, and I forget if that was 2020. The pandemic screws up with my mind. I think it said September 2020, and it was March 21, so it wasn't that long ago. That you needed to replace the stickers or the batteries. The sticker said replace batteries by September 2020. It was March 2021. We went well past the mark, and 1 battery out of 36, it was a 15 kVA, and if I remember right, I think it was 36 batteries. 1 battery had a short, and that's where that smoke was coming from. The dealer said, hey, can I just bypass this UPS and we can give the power over to the connected load while we work on this UPS? Well, we could have done using just the internal bypass, but we were afraid, not knowing what we were dealing with remotely, we were afraid we might be dealing with something catastrophic in the UPS. And from that moment on is when Vince and I said, hey, if you're buying a large format UPS, you probably want to do an external bypass, because what that allows you to do is if anything were to ever happen in a bad way with that UPS, if you've got mains power, it's just going to go around the UPS then and bring mains power to the connected load.
Yeah, and then what that allows you to do, it allows a technician to completely remove that UPS and maybe replace it with another one. It just depends on what the issue is, on what they need to do. You'll notice that the large format UPSs do have an internal bypass in them, which allows a technician to switch, to throw that switch. It will bypass it internally, and they can safely work on all the PC boards inside the unit. But in the event that the unit needs to be taken out completely, that's where the external maintenance bypass switch comes in handy.
Okay. Yes. Thanks, guys. Oh, there we go. Like to break out of multiple 10s. IP control of the bypass or remote bypass. IP control. So we do not have IP. In fact, I think it's a key, if I remember right.
There's an option for a key lock to prevent someone from doing it.
Okay, yeah. We do not have that IP control though.
No.
We do have an IP card that we include with the UPSs, every one of them. And that is something you might be able to use with, say, Crestron or Savant, where if we said our status is 0 input voltage, our battery health is down to 10%, our output voltage is X, whatever the case is, you could make decisions on what the macro command would need to be on connected equipment, not necessarily breakers, unless maybe it was the Savant system and they were able to somehow trap. And then Savant system has relays that they can allow voltage to flow through or not.
Or turn things off.
Yeah.
Conserve battery by turning off loads. but that is external to anything that we currently provide.
Mhm.
We're hoping in the very near future to, again, we're planning on expanding our line of to include power control products. So be on the lookout for announcements in the near future on that.
Yeah, all right. So, thank you so much. Many of you are already customers of Apex, so we just would love to be a part of what you're already doing, so that your experiences can just be awesome,
Yeah.
because they already are. But with a little help on the power side, maybe they can continue to be awesome more time than, you know, having some slight interruption here and there. If anybody needs more information about power, please, if you've got our contact or Ryan's contact, get us directly. We all use the same email address as Ryan. It's just going to be our name, Vince or Jimmy at apex-tech.us. Get a hold of Ryan if you need our phone numbers. Call us. It will help with the design, whatever systems you're looking at. Just tell us what your end game is, and we'll, you know, focus on that as we design systems.
Very good.
Sometimes we get to sell something out of that. Sometimes we tell you there's a better product out there.
Yeah.
Yeah.
Thanks, everybody.
Yep. Appreciate it.